Determine the points, if any, at which the graph of the function has a horizontal tangent line. Okay, so to have a horizontal line, we need a slope of 0, and a slope of the tangent line will be the derivative of this function at that point. So let's start off by finding the derivative. So using the power rule here, I can bring the power down, lower the power by 1. The derivative of x is just going to be 1. And the derivative of sine is cosine. That one you just need to memorize. And so what this tells me, for any x, I can find the slope of a tangent line. Now the parameters of this question say between these values. Since this goes back and forth, it would have infinitely many horizontal tangent lines. We only want to find the tangent lines between 0 and 2 pi. So again, a horizontal line is going to have a slope of 0. So I'm interested in, when does this equal 0? Now to solve this, we need to subtract the 1 over. And we need to ask ourselves, we can't really undo a cosine. That's not how that works. This cosine of x is all together. Cosine is a function of x in this question. So don't try to like divide both sides by cosine or anything like that. That doesn't make sense. We have to ask ourselves, when is cosine equal to -1? So from the unit circle, cosine are the x values around the unit circle. And the only place where there's an x of -1 would be at pi radians. And so that would be the x value that would have a horizontal tangent line. And then the y value, we would need to plug that back in up here in the function. So x plus sine x, and the sine of pi would be 0. So for this function, at x value of pi and a y value of pi, you should have a horizontal tangent line.